Hello, good morning students. Today I would like to discuss about the one of the important question for the IPE point of view for Telangana and Andhra states. The question name is nuclear reactor. Explain the principle and working of a nuclear reactor with the help of the label diagram. That is the question. It is continuously they are asking the question along with a small problem. So first of all, in this question, principle. What is the principle involved in this? That is, nuclear reactor works on the principle of controlled chain reaction for producing nuclear energy. That means it controlling the chain reaction. So what do you mean by the chain reaction? Actually, you have to know what do you mean by the chain reaction. Chain reaction means if you take a uranium 92-238, when it is bombarded with the thermal neutron means its energy, its kinetic energy is about 0.025 electron volts. When it is bombarded to the uranium nuclei, it will be splits into krypton and barium. Along with that, 3 neutrons will be coming out. Again, these 3 neutrons bombarded to the 3 uraniums, again it will come 3 into 3, 9. So in the so on, that we can call as the chain reaction. So actually, if you want to easy to understand, if you see the Telugu movie, that is a Stalin, you have to help one person, so that he should help 3 persons, and 3 persons will become helping to some more 3 persons, and so on. That is Stalin reaction. So whereas in this case, this is the chain reaction. So actually we say that the average production of the neutrons in the chain reaction is around 2.5. So that is also very important question. See, that chain reaction will be controlled so that heat energy will be released. So that means nuclear energy will be released, it will produces the heat energy. That is the principle of the nuclear reactor. Now point number 2. What are the parts of the nuclear reactor? So as we know that in the nuclear reactor, mainly it will having 5 parts, 5 or 6. In some books they will give 6 parts. Here we have 5 parts. Number 1 is fuel. Number 2 is moderator. Number 3 is control rods. Number 4, radiation shielding or protective shielding, you can say. Number 5 is coolant. So all the parts, how they will work, let us discuss. Number 1, fuel. Fuel means it is a fissionable material used for producing energy by fission, is called nuclear fuel. So it is a fissionable material. Fissionable means nuclear fission which occurs in the nuclear fission. That is a heavy nuclei splits into 2 or more smaller nuclei, which we can call as the fission. So for example, they will give uranium 235, plutonium 239 and some thorium, etc. These are the used as the nuclear fuel. Okay, these are taken in the form of the thin long rods. So if you see the diagram, this one is the diagram. Let us check the diagram. See, this is the diagram. So number 1, if you see moderator, these are the available in the form of the rods. That may be uranium 235 or plutonium 239, etc. These can be used as the fuels. Next will be moderator. So what it will do? Moderator means it slow down the fast moving neutron to thermal energies. They were allowed to pass through the moderators. Say example will be heavy water, graphite. These are the best example for the moderators. So actually moderator, what it will do, when the chain reaction is going on, all of a sudden we are unable to control the chain reaction. First of all, you have to slow down the chain reaction and then control. For slow down purpose, moderator is used. So we can say that to slow down the fast moving neutrons, moderator is used. The example for the graphite and heavy water as the best example for the moderator. And then after slow down, you have to control the chain reaction. That's why control rods are used here. If you see in the diagram, the control rods will be, these are the control rods. What it will do, it control the chain reaction by absorbing some neutrons. Okay, that's why here they given control rods are used to absorb neutrons releases nuclear reactor, just like cadmium, boron rods are the best example for the control rods. So by the suitable movement of these rods into the reactor core, the reactor can be start up or shut down. So by using these control rods, if any problem will occur, if you want to shut down the process, total process, simply you can shut down the process by using the control rods also. Okay, that is about the control rods. So first of all, three parts we discussed. Number one is fuel, which is a fissionable material like uranium. Moderator, it slow down the fast moving neutrons. Control rods, it control the chain reaction by absorbing some neutrons. That is the three points. Okay, now next, if you see the fourth point, what is the one? Protective shielding. See, protective shielding, what it will do. So fourth point from the diagram you can observe, this total will be the protective shielding. So this is concrete wall, is there? Yeah, concrete wall. This is the protective shielding. Okay, what it will do? Generally it is thickness is about 1 meter thickness, made up of concrete and steel. So look at this one. Nuclear radiations like beta and gamma rays are emitted due to the fission reaction. In addition to neutrons, so suitable shielding such as steel, lead, concrete, etc. is provided around the reactor to absorb and to reduce the intensity of emitted radiation. So which is not harmful to the operating person. So that is about the protective shielding, which is a thick wall like this. Next, the energy released in this, if you see the items, this is the aluminum cylinders. This is generally fuel will be in this part, uranium-235. This is aluminum foils, it will be preserved in the aluminum foils. These are the moderators. Okay, these are the control rods. So this is the diagram. Now from this diagram, radiation will be produced. So due to this chain reaction, nuclear radiation will be produced, which is passing through these pipes like this. So this total will be kept in a water containing reservoir. This is the water containing reservoir. Whenever the radiation goes into this pipe, which is put in the water tank, this water will be heated. At sometimes, due to the more heat, these pipes may break or some dangerous things will be happen. So that we have to cool this always they are producing the radiation, they have to cool here. That means the coolants here used. So what are the coolants here they used? So heat generated in the fuel elements is removed by using the suitable coolants to flow around them. So always it will flowing around that rods. Substances used for the coolants are water at high pressure, molten sodium. These are the best examples. So by pouring the water at the high pressure and molten sodium. So here you have to one thing remember, water is used as a coolant in the nuclear reactor. Why? Because it is having the highest specific heat. That is also important point. So this is about the coolant. Okay. Now how it will work? This is the diagram. Okay. How it will work? Simply you can add by removing the all side headings, you can write once again, and finally you have to write the two lines, or otherwise look at this derivative. Working. Uranium fuel rods are arranged in a graphite blocks with equal separation. Graphite blocks acts as the moderator. Control rods are placed in the holes of the graphite blocks. If 1 neutron initiate the fission uranium-235, fast neutrons are produced. So already previously we discussed all the things. These fast neutrons passes through the moderator to become thermal neutron. Okay. These thermal neutrons produced fission with further nuclei and proceeds the chain reaction in the controlled conditions. So they explain about the chain reaction. Cooled water is heated by using the generated heat and high pressure steam is produced. Now the steam is used to rotate the turbines to produce the electricity. So look at this one. Whenever heat will be passing through these pipes, the water inside the water tank will be heated and produce the steam. The steam will be come from this outlet. This is allowed to passing over the turbines, which is here. Due to the rotation of the turbines, power will be generated. So this is the principle and parts and working of the nuclear reactor. Along with this, a small problem will be there. See, this is the problem related to this. If 1 microgram of uranium-235 is completely destroyed in an atom bomb, how much energy is released? That is a question, simple question. So what are the, first of all, what is the given values? First given solution is mass is given here. Mass m is equal to how much? 1 microgram. So you have to convert it into kg. That is how 1 into micro in the sense 10 power minus 6, gram in the sense 10 power minus 3. That is equal to how much? 10 power minus 9 kg. So this energy is released. So completely destroyed. The question here is completely destroyed. So how much energy is released? As we know that energy E is equal to, the formula is mc square. Okay. Now as you know that mass is given. C means velocity of light. What is the value of velocity of light? Velocity of light. That is equal to 3 into 10 power 8 meter per second. Simply substitute it. What you will get? E is equal to 10 power minus 9 into 3 into 10 power 8 into 3 into 10 power 8. That is, if you calculate 3 3 is 9. 9 into 10 power, see, minus 1, you will get 7. So 9 into 10 power 7. Energy means joules. So the answer will be E is equal to, energy released here is 9 into 10 power 7 joules. This is the attached problem it will ask. Okay. Thank you for watching. All the best for exams.